Our last lecture on section 4.2 will deal specifically with constructing polynomials when we are given the zeros. So we're going to jump in with an example. This will be example 6 in your textbook. And the example is going to ask us to construct a polynomial that has the given properties. And part A says that it needs to be a third degree, which means that the highest power needs to be 3. And it needs to have zeros of -3, 2, and 5. And that it needs to go to negative infinity as x approaches infinity. So initially, let's deal with the zeros. So if I know that I have a 0 at -3, then what that means is that I had a factor that looked like x plus 3. Because remember that in order to go from the factors to the zeros, you're going to set that equal to 0 and solve. So the only way to make this factor turn into 0 is to put a -3 in for the x. If we have a 0 of 2, we'll need a factor that looks like x minus 2. Again, because if I put a 2 in for the x, 2 minus 2 gives you 0. And for the 5, we'll need an x minus 5 as a factor, because 5 minus 5 is equal to 0. Now, this will be a third degree polynomial because when I multiply it out, my highest power is going to be x to the third. Okay, look at this and we'll multiply it out on the next screen, but look at just multiplying those first terms together tells you that the first term is going to be x cubed, and then you're going to have some other terms to follow. So we have the third degree, we have the zeros taken care of. Let's look at this idea about the function going to negative infinity as x approaches infinity. All right, so here is our function, x plus 3, x minus 2, x minus 5. This is what we have so far. Our question is, does the function approach negative infinity as x approaches infinity? And the answer to that is no, because if we multiply it out, as we've already talked about, the leading term on the polynomial will be x cubed. And we've already said that if we go to multiply this thing out, the first term is going to be x cubed, and then we're going to have some other terms. And so the fact that that x cubed is positive, that means that it's going to be approaching positive infinity, where we want it to approach negative infinity. So to fix this, we're going to multiply our polynomial by -1. All right, and so we're going to go ahead and multiply this thing out. We can do that with the FOIL method. We're going to multiply that -1 on at the end, and we have our function that meets all 3 criteria now. Okay, all right, so let's go back to our problem and let's look at part B. All right, so part B asks us to do a 4th degree polynomial, which means that the highest power will be 4. It gives us zeros of -5, so that's going to be a factor of x plus 5. -2, that's going to be a factor of x plus 2. +1, which is going to give me x minus 1. And +3, which is going to give me x minus 3. So there is my polynomial with all the zeros. It is 4th degree, because if you multiply the x times the x times the x times the x, the first term is going to be x to the 4th with other terms to follow. And the only thing we have to concern ourselves with is the y-intercept. Now, remember that the y-intercept is found by plugging a 0 in for the x. So we want to be sure that when we put a 0 in for these x's, that we're going to end up with 15. So let's just try it and see. So I'm going to stick a 0 in right here, right here, right here, and right here. And let's see what we get. So that's going to give me 5 in the first one, and 2 on the second one, and -1 on the third one, and -3 on the second one. So 5 times 2 is 10, times -1 is -10, times -3 is +30, and we wanted it to equal 15. So we need to consider how we're going to make this adjustment. So let's look at what they do. Here's what we have so far. All right, and we've already shown that if we substitute an x in for 0, then we get a 30, and we were supposed to get a 15. And so one idea is to try to subtract the 15 from the polynomial, because you know that this part's equal to 30, so subtract 15 and you would get 15, which is what you wanted. But the problem with that is if you do that, then you then change all of your zeros into something else. So we don't want to approach it that way. All right, so instead we're going to multiply it by a half. We're getting 30, we really want to get 15, so we're going to multiply by a constant of a 1/2. And as long as we're multiplying by something in the front, it's not creating another zero, and it's not changing the zeros that we already have. And so again, we could take the time to actually multiply this thing out using the FOIL method, and then multiply by a half. And if we do that, we are going to get this 4th degree polynomial that satisfies the conditions that we're asked to satisfy.